This research paper introduces uRAG, a novel framework that unifies multiple retrieval-augmented generation (RAG) systems, each performing unique tasks such as open domain question answering, fact verification, and entity linking. The proposed framework consists of a shared search engine that serves multiple RAG models, enabling the development of a large-scale experimentation ecosystem. This ecosystem allows for the evaluation of various research questions related to the development of search engines for machines. The authors highlight the limitations of current machine learning systems, which are designed as self-contained systems, and propose the use of retrieval-enhanced machine learning (REML) to address knowledge grounding issues. They introduce a generic training guideline that standardizes the communication between the search engine and downstream RAG systems, enabling the optimization of the retrieval model. The experimentation ecosystem consists of 18 RAG systems that engage in training and 18 unknown RAG systems that use the uRAG as new users of the search engine. The authors answer several research questions, including the performance of unified re-ranking compared to training individual re-rankers for each RAG model, the impact of personalization on performance, and the generalizability of the retrieval model to unknown agents and new datasets. The results show that unified re-ranking performs either on par or significantly better than individual re-rankers, and that knowledge transfer can occur across datasets. Personalization does not demonstrate significant improvements, but the authors acknowledge that this may be due to the limited number of users in their experimentation ecosystem. The unified re-ranking approach also performs well for new, unknown RAG systems and datasets, demonstrating its generalizability. The authors conclude that developing a unified search engine for machines is a promising research direction, and that their framework provides a foundation for exploring personalization and generalizability in the context of uRAG. They also identify limitations and areas for future work, including exploring personalization with a larger number of users and evaluating the performance of uRAG on entirely new tasks. The paper further explores the development of a unified search engine for machines, specifically designed for multiple RAG models. The authors investigate the effectiveness of unified re-ranking in various scenarios, including when the model architecture and task are unknown to the search engine. They find that unified re-ranking struggles to improve BM25 in such scenarios, highlighting the need for further research in this area. The authors also examine how the performance of unified re-ranking, uRAG, improves with the amount of training data provided. They observe that performance often improves as more training data is introduced, suggesting that incorporating more data and RAG systems into the uRAG framework could lead to further performance enhancements. The paper provides an overview of knowledge-intensive language tasks, which require access to external knowledge sources to retrieve essential information. It also discusses retrieval-augmented generation, RAG, a paradigm that integrates information retrieval and natural language generation to enhance the quality and relevance of generated content. The authors emphasize the importance of optimizing retrievers in RAG pipelines, citing various studies that have explored joint training of retriever models and large language models. They differentiate their work from prior research by assuming that large language model parameters in downstream models are not accessible to the retrieval model and focusing on scenarios where multiple large language models use a shared search engine. The authors introduce the uRAG ecosystem, where machines, such as large language models, engage with a retrieval model to acquire essential knowledge for executing their designated tasks. They formulate uRAG as a search engine that provides access to information from a corpus to a set of RAG models, with the goal of delivering search results that benefit the downstream task conducted by each RAG model. The optimization process in uRAG involves each RAG model engaging in an optimization process with the search engine, with a predefined training guideline that includes a training set, query construction, and utility function identification. The primary goal of the search engine is to minimize the loss function defined based on the received utility values from downstream models. The proposed uRAG system aims to develop a unified ranking model for multiple retrieval-augmented large language models, utilizing 18 RAG models trained on different datasets and tasks. Each model is fine-tuned using the AtomW optimizer with a weight decay of 10 to the power of 2 and a learning rate of 510 to the power of 5 for 10 epochs. The authors employ 3 retrieval-augmented large language models, RAT5, RABERT, and FID, each trained on a different dataset or using a different large language model. The utility functions assigned to the RAG models are based on the evaluation metrics outlined by the KILT benchmark. The search engine implementation in uRAG adopts a two-stage cascaded retrieval pipeline. The first stage uses BM25 to retrieve 100 documents, and the second stage employs a cross-encoder reranker to re-rank the documents. The reranker is trained using a binary cross-entropy loss function, and the model is optimized using the Atom optimizer with a learning rate of 10 to the power of 5 for 2 epochs. The unified re-ranking model is evaluated against individual retrieval models for each RAG model and a retrieval model trained on the feedback obtained from all RAG systems that use the same dataset. The results show that the unified re-ranking model achieves better performance for 78% of the models, with statistically significant improvements in 11 out of 18 downstream models. The unified retrieval model also outperforms the retrieval model trained on the feedback obtained from all RAG systems that use the same dataset for 72% of the models. The research paper further explores the concept of a search engine for machines, focusing on unified ranking for multiple retrieval-augmented large language models. The authors investigate the performance of various re-ranking models on different downstream tasks and datasets. They examine the impact of personalization on the search engine for each RAG model, finding that personalization leads to an improvement on average across all users, particularly in question-answering tasks. The authors also assess the performance of unified re-ranking for new, unknown, RAG systems that use an observed, known, dataset, known RAG systems on a new, unknown, dataset, and known RAG systems on entirely new tasks. The findings highlight the importance of personalization and unified re-ranking in enhancing the performance of search engines for machines, with implications for the development of more effective search engines that can accommodate diverse language models and tasks. This research paper introduces the concept of a search engine for machines, focusing on unified ranking for multiple retrieval-augmented large language models. The authors propose the uRAG ecosystem, which enables large-scale experimentation to address fundamental research questions in this area. They investigate the performance of a unified re-ranker in various scenarios, including with new, unknown RAG systems and datasets. The results show that optimizing a unified re-ranker leads to significant improvements compared to the current standard recipe of learning a retrieval model per downstream RAG model. The unified re-ranker generalizes well to new, unknown models based on known datasets or unknown datasets closely related to those used during training. However, the performance drops when the task is substantially different from those used during training. The authors also explore the effect of varying the amount of training data on the performance of the unified re-ranker. They find that even with 25% of the training data, the approach outperforms the baseline trained on the full datasets. The optimal performance is achieved when utilizing 75% of the training data for some datasets. The paper highlights the challenges of personalizing re-rankers for downstream RAG models and generalizing to unknown downstream tasks. The authors propose several future research directions, including optimal aggregation of feedback from various downstream RAG models, calibrating their feedback, and expanding the work to retrieval model optimization. The paper concludes by discussing the potential applications of the proposed approach in developing a search engine for machines. The authors provide a comprehensive list of references, which include relevant works on large language models, retrieval-augmented generation, and knowledge-intensive NLP tasks. The proposed framework is designed to optimize the retrieval quality in retrieval-augmented generation. The authors argue that existing methods focus primarily on the generation quality, neglecting the retrieval quality. They contend that a unified ranking framework can effectively balance the trade-off between retrieval and generation, leading to improved overall performance. The authors outline several key components of their proposed framework, including a symmetric dual-encoding dense retrieval framework, a mutual learning framework for open domain question answering, and an expected utility maximization approach for end-to-end retrieval-augmented generation. They also highlight the importance of personalization and domain adaptation in retrieval-augmented generation, citing recent works on LAMP and fresh LLMs. The paper concludes by emphasizing the need for a comprehensive evaluation framework for retrieval-augmented generation, including metrics for retrieval quality, generation quality, and overall performance. The authors suggest that their proposed framework can serve as a foundation for future research in this area, paving the way for the development of more effective and efficient retrieval-augmented generation models.